Welcome to another week of our 1211 lab here in North Georgia. This week what we're going to be taking a look at is enthalpy of neutralization. And so you'll see a setup here that actually looks probably a little bit similar to some things we were working with just a couple weeks ago, or maybe just a week ago, depending on how fast your program's going. And what we're going to be trying to do is really look at the energy that's released by an acid-base reaction. That's kind of our goal. We're going to be doing that by basically doing a reaction of an acid and a base in one of our styrofoam cups, similar to what we've used previously. And we're going to monitor the temperature change. And by monitoring the change in temperature of the water, we can hopefully get an estimate then of how much energy our reaction released. And then if we know the concentrations of our acid and base we reacted, a little bit of stoichiometry can help us figure out how many moles are reacted, and now we can figure out the energy released per mole. It's kind of the path we're going to try to take to figure out how much energy these neutralization reactions are releasing. Now, one other thing we're going to kind of take into account in an effort to try and be as accurate as we can be with our data is we're actually going to do this experiment in two parts. So the first part of this experiment is actually going to look at dealing with just hot and cold water and not an acid or a base. And what we're going to do is we're just basically going to take hot water and cold water. We're going to mix them up in our little calorimeter cup that we'll be using later for the acid-base reaction. And what we're going to basically try to do from this part of the experiment is figure out how much heat is this cup and just the general surroundings going to normally absorb as we mix hot and cold water. That'll give us an idea of then the calorimeter constant that we can use and treat in the second part of our experiment when we go to figure out how much energy our neutralization reaction will release and we actually react the acid and base in that portion. So those are going to be kind of the two main parts of our experiment. I'm going to show some quick setup things here. And so in general, I do have here, looking at the first part of our experiment, we just want hot and cold water. So I have two different 50 milliliter graduated cylinders filled pretty much right at 50 milliliters, just a little bit different. I'll have these exact numbers in a table that'll kind of summarize all of this in at the end and kind of go over things like I've done before too. And what I'm going to do is basically just take 50 milliliters of the hot water. So I'm going to take my 50 milliliters here of the hot water, and this one's actually just under 50. And it's important that I do have that exact measurement because that is something that's going to influence, right, the mass of water. Because anything, if we're doing temperature changes and looking at heat, Q equals MC delta T being our equation, we do want to know the mass as accurate as we can. So what I'm going to do, I'm going to go ahead and take that 50 milliliters of water that I'm going to go ahead and heat up. I'm going to heat it up on a hot plate. I have a thermocouple over here that I've got set up that I was waiting to kind of do this with. And what I'm basically going to do is get my thermocouple set up here just into the water itself so that hopefully it's not touching the bottom there. Right. Okay. And what I'm going to do is I'm going to go ahead and heat this water up to somewhere around 40 degrees Celsius or so not terribly hot. And I have a LabQuest here that I can monitor my temperatures with. And we see the temperature already starting to go up. It's a little bit over 25 now. And so I'm going to let this heat for a couple minutes. So I'm probably going to cut the video here. What I'm going to do is I'm going to let that heat for about 20 minutes. The cold room temperature water is what I'm going to actually put into my styrofoam calorimeter cup. Be careful to get all of it in there without splashing anything. And now what I'm going to do is I'm going to go ahead and monitor the temperature of this one as well, but not until I'm actually ready to kind of start all of the experiment. What I'm going to end up doing, I'm going to heat this hot water up to, like I said, about 40 degrees. I'll shut this off here in a second until it gets up there. And then what I'm going to do is basically take it off the hot plate, let it kind of start to cool down, keep the two solutions separate, and we're going to measure their temperature for a period of 5 minutes. And then we're going to go ahead and mix the two solutions of water together and measure the temperature again for 5 more minutes. And that's going to be all of the data we're really collecting in the first part of this experiment. Normally you do this experiment 2 times. On video I'm going to show it once. At the end though I'm going to provide data for 2 full trials so that you can kind of look at that and kind of figure out which trial you think looks better to use for your calculations. Again, I'll talk more about that as we get there as well. But for right now I'm going to go ahead and kind of cut the video over for just a moment. When I come back we'll see our temperature up over 40 degrees and we'll actually get started with the experiment itself. Alright, so at this point, I've gone ahead and heated my water up to 40 degrees. I've actually taken it off the hot plate and letting it cool down. I see it just got under 40 degrees now, which is actually what we wanted. We wanted to start somewhere between about 35 and 40 degrees when we start collecting data. And so what I'm going to do, you see I have right here, I have a cold water solution. Here I have my hot water solution, roughly about 50 milliliters of each. Again, I'll have the exact data here at the end in a minute we'll talk about. And what I'm going to do is I'm just going to go ahead and tell this to start recording. And what this is going to do now is it's basically going to record on the LabQuest the temperature over periods of time. So if you're looking in the procedure, it has you basically take a thermometer, just measure the temperature of each solution every 30 seconds. We're going to make it easier than that. We're actually going to have the LabQuest record all this data for us. And then what we can do at the end, I can give you guys an actual Excel file that have all the data nicely tabulated for you to look at. And you can take the data pieces that you want at the different time intervals out and go ahead and put into the tables that CSV Pub will ask for. But I think the Excel file is just a little bit easier, I think, to kind of work with and give the data to everybody in that format. And so I'm going to go ahead and just record in the lab quest. We'll have a nice visual picture here that I can talk about as well. And what I'm going to do is I'm going to wait for this timer to get to 300 seconds. It's set to record for 600, which is 10 minutes. Because at 5 minutes, that 300-second mark, that's when we're going to go ahead and mix our hot and cold water solutions together. And once they've been mixed, then what we're going to go ahead and do is continue to record for 5 more minutes. But we should see kind of a nice plot of basically a high temperature. And if you're actually looking, if you can see the plot here at all, we have a high temperature and a low temperature that should basically come together. And then we can measure and figure out what our final temperature of our solution is going to be from looking at that information. And so I'm going to stop this rather than make you just sit here and watch this for another 3 or 4 minutes. I'll show you kind of the mixing step very briefly, and then I'll show you kind of what the end data looks like at the end of this trial. All right, so we're quickly approaching the 300-second mark here, about at the halfway point. So what I'm going to do here to mix these two solutions, I'm going to go ahead and bring my cold water solution over because that's what I'm going to be pouring everything into. And I'm actually going to go ahead and put my thermometer in there for the other one quickly and mix all of this together. And so I've added now my hot water to the cold water. It's important I did it in this order so I keep everything in this particular styrofoam cup. And this is where I'm going to keep everything. And now at this point, what I'm going to do is I have my 2 thermocouples in the solution. I'm going to make sure it's mixed here pretty good at the start. And I've been blocking probably the view here of our graph. But our lab quest section going to collect all this data, and we actually see our temperatures kind of converging on each other, which is a good thing. And what I'm going to do now is record this temperature for 5 more minutes. And then I'll show you kind of what the final plot looks like and kind of what we can be doing with that data here in just a moment. All right, so we've gone ahead and finished the experiment. And what I just wanted to show you here is just kind of the lab quest plot of what it's showing us. We have like our hot water temperature being measured up here. That's going to slowly decrease until we mix things. Cold water temperature is pretty much constant. And we see that as we mix things together, and apologize for the little bit of glare that we have there, we see these two temperatures kind of come together right here in the middle, right? And so that's good. So we expect to see. The thing I will say here as we're looking at this, the data in particular, when we go to do our actual calculations as far as like delta T's and things like that, your initial temperature for the hot water should be this last temperature right up here before it drops down, right before you mixed. Same thing with the cold water. You want the temperatures right before mixing, and then you want for your final temperature kind of what everything came together at here in the middle, what that temperature looks like it stayed. It looked like it stayed in the kind of that same range for quite a bit. And so what I'll do is when I'm done with this experiment, I'm going to take all of the data from this lab and have it in an Excel file, and you'll have that Excel file accessible where you can actually see all of this data, get out the information that you want so that you can then do all of your calculations. But I'm going to stop here for the first part. Now we're going to move into part 2 of the experiment where we actually do the acid-base reaction. But before we do that, we do have a dilution to do for our acid solution before we use it. All right, so to make our acid solution, we want 100 milliliters of a 1 molar HCl solution. That way we'll have enough to do 2 trials that'll use 50 milliliters each of that HCl solution at 1 molar. The stock solution you're given usually for this lab is 6 molar HCl. That means you do have to do a little bit of a calculation to figure out how to do your dilution properly. So if we know we want to end up with 100 milliliters of 1 molar HCl and we're starting with 6 molar HCl, it should only take about 16.7 milliliters of that concentrated 6 molar HCl, basically then diluted to 100 milliliters with water to get our proper final concentration. And again, to figure that out, you can do your M1V1 equals M2V2 equation for dilutions to kind of piece through that. But what I have here, I have about almost exactly 16.7 milliliters of HCl measured out in a graduated cylinder. I'm going to go ahead and add that to my volumetric flask. And then what I'm going to do is kind of dilute things down. And similar to past times when I've made solutions here, generally when we're making our solutions, what I'm going to do now is fill it up with water, not all the way to the line on my volumetric flask, but somewhere just kind of close, like on the neck probably somewhere, at the start of the neck usually. And then I'm going to stir the solution up and mix it up together very well. And the purpose of that is just to make sure we get everything thoroughly mixed before we get our solution kind of all the way full and kind of try to expect it to be exactly perfect volume before mixing, because when we mix it, that volume might change ever so slightly. So I'm going to go ahead and continue to add a little bit more water here. It's actually probably enough for me to go ahead and start mixing this some. So I'm going to start mixing it up. And remember, as you mix it, kind of what we'd said before as well, don't forget to go ahead and vent a little bit as well, just in case there is any pressure buildups. With just water and HCl, we don't expect there to be a lot of built up pressure, but it's not something you want to risk by just constantly shaking and not venting, because if you don't vent and there is some pressure buildup and it's HCl that's in here, you're going to spill acid all over your hands. So if you're not wearing gloves, like I'm not at the moment, that could be then a problem. You don't want to spill it on your hands. HCl at a concentration of 1 molar, thankfully, which this probably isn't quite that dilute yet, even at 1 or 2 molar, it's a low enough concentration it's not going to do severe damage, but probably you will feel the tingling sensation, and you'll want to wash it off immediately. Again, if you want to, if you're a little more afraid of any of these chemicals, or if you are just not comfortable handling everything glassware-wise, I do encourage for things like this wearing gloves until you have a little more lab experience and kind of become a little more comfortable with doing those things. I'm going to go ahead and at this point, now that I've mixed that up pretty good, I'm going to go ahead and add some more water up really close to my line, probably mix it once or twice more, and then I'll go ahead and get it to that actual final volume. And I have a squirt bottle, doesn't squirt very fast because I was actually hoping to control it good at the end to hopefully get pretty spot on for our final volume, so hopefully that will work out well. So I'm going to mix this up a couple times here. And then what I'm going to do is go ahead and add this last little bit of water to hopefully get our volume spot on. And again, remember what I'm doing at this point is looking to get that water exactly on that line for my volume. And it looks like I'm pretty much dead on as far as the meniscus here being right on the line for my volumetric. And so now at this point, I'll mix this one last time here, but I should be good to go ahead and divvy this out and get ready to do my acid-base reaction. So the next part of this that I'm going to be doing is now I'm going to be reacting this acid and the base, and the only thing that's going to be different from the first time is I don't have to heat anything. Right? The first part of this experiment we had hot water and cold water. This time I'm going to have basically just an acid and a base. They're both going to be approximately room temperature. So I'm going to use just the same beaker and styrofoam cup that I used previously, but which one I use doesn't really matter for which. As long as everything ends up in the styrofoam cup for making my final measurements, then that should be the only thing I really have to worry about for any of this. Now, in terms of adding everything here, I do want to go ahead and measure out. I don't want to use actually the same one. I'm going to use the clean 50 milliliter graduate cylinders I've been using before. So I want to measure out 50 milliliters of now my acid solution so that I can add this to one of my cups here for the experiment. And I'm trying to be very careful pouring this last little bit. Right, should be almost right on 50 milliliters. Maybe like 49.95 or something just barely underneath, which is perfectly fine as long, again, it's like record that value, should be good. And then for my base, I'm going to do the same thing. And I actually have a pre-made sodium hydroxide solution back here. This is what we normally give in lab. It has a concentration of 1.05 molar already. And what I'm going to do is I'm going to, again, get 50 milliliters of this one as well. So I'm going to measure out, again, not in that graduate cylinder, this one. And I want 50 milliliters now of my sodium hydroxide solution. And I'm just going to add, in this case, I'm going to go ahead and put the sodium hydroxide into the beaker and the acid into the styrofoam cup. But which one goes where really doesn't make any difference. That should be pretty close, about 49, maybe 0.90. And so what I'm going to do now, I'm going to go ahead and add, like I said, sodium hydroxide, so my base to my beaker. I'm going to add my acid to the styrofoam cup. And now what I actually want to do with all of this, I'm going to keep my acid and my base here and the ones that I just used for each all organized. And what I'm going to do is measure the temperature of each of these just on their own, sitting here, now that I've made the solutions, for about 5 minutes. And then I'm going to mix them, kind of the same thing I've done before. So I'm going to go grab my LabQuest again here. And get my LabQuest set up to record this information for me. Sorry, I have my thermocouples here coming detached. The LabQuest to kind of update. There we go. All right, and so this time, the red temperature, the top one, I'm going to put it with the beaker again, which is the same thing that I had previously. And then I'm going to have the blue temperature, which is going to be the bottom one that you see here on the LabQuest. If I pop it up, so hopefully you can see the temperatures okay. If I back this up just a little bit so you can actually see them. And so blue going in the styrofoam cup, red going into the beaker. And what I'm going to do is I'm going to leave these, and hopefully these temperatures should be reasonably close together, should be pretty close to room temperature, since that's kind of where we've been working with everything at. And what I'm going to do is record this temperature for 5 minutes. And so you're going to see that here. I'm going to clip this on the video so that you don't have to just stand here and watch for 5 minutes while I kind of hold stuff. And then what I'm going to do is mix things together. So I'll show the clip again of mixing together, and again a clip of kind of the end data of what everything looks like on the LabQuest quick, and kind of summarizing what to expect and what to look for. All right, so I'm about 10 seconds away from that 300-second kind of midpoint in all of this, and so I'm just going to be very careful and kind of moving things over here. So I'm going to go ahead and move my first thermometer over and add, in this case, my base solution to my acid. Again, which one you add to which doesn't really matter. I really just want to make sure they're both staying in the styrofoam cup. And so here I have my styrofoam cup that I have both of my thermocouples in. And we should hopefully now see actually our temperature hopefully spike. In fact, if you see here, we have the two lines mixing together and everything shot up really high. So that's a good sign, right? We mix an acid and a base. We should know hopefully from some previous experience that it does get hot when that happens. It's kind of what we're looking at in this experiment, is the energy release that occurs in that reaction. One thing I'll kind of point out, and I'll say this again when we look at the data later, the temperature of the water is going way up, but the water is going up because it's gaining the heat. That means the reaction's releasing it. So this is a very exothermic reaction, right? The energy in this reaction is being given off by the reaction. So it is going to be a negative delta H that you hopefully eventually find when we get to the end of our calculations. But now what I'm going to do is basically monitor this temperature for the rest of the 5-minute time interval now that we've mixed. And then I'm going to basically do this trial, this experiment one more time for a second trial so that I have full data. What I'll do is I'll show you kind of a picture of this when it's done, and then I'll kind of talk a little bit about the Excel spreadsheet that we'll see with all the data in it as we finish as well. All right, so quick look just at this data before I send everything back to everybody. If we're looking at it here, it looks like we have our initial temperatures kind of starting out at the bottom, apologizing for the glare. And so we see our temperatures down here are pretty constant. And as soon as we mix these two solutions together, we see that huge temperature spike before it starts slowing down. So again, kind of just where the data is going to come from here, your initial temperatures for your base and acid solution should be whatever they are right before they get mixed. And your final temperature is really kind of your peak up here that everything gets to. And again, I'll have the Excel data sheet with all of this information in Excel format for everybody to look at as well for both trials, for parts 1 and 2 of this experiment coming up as the next part, where you can then, and I'll kind of talk a little bit about how to use some of that data to get into our calculations. In terms of cleanup, usually for this lab, everything's just, once the acid and base have reacted with HCl and NaOH, it's very similar concentration, so pretty much the product that's left is just sodium chloride, table salt. So actually everything for this lab, as long as it's all been neutralized, can usually just go down the sink with a little bit of water just to dilute anything that maybe wasn't fully neutralized for any reason. So pretty easy cleanup on this one. But if you do have any of the leftover, like starting 6 molar HCl, that you'd probably want to take a little more precaution. We try not to add it back into the original container just to avoid contamination usually. But that is something that would then you'd probably want to neutralize some first before you would actually just put that down the sink. Like the 1 molar solutions, if you have just a little bit of them, if there's enough water, you can usually pretty safely put them down the sink if you just dilute them with water and run the water basically in the faucet as you get rid of them. But 6 molar, probably pushing a little bit, so we want to probably neutralize that before we get rid of it if we did have any excess. But besides that, I think that covers everything from the experimental side. So I'm going to show one more clip here. You'll see the next clip of this. That'll talk a little bit more about the data. I'll show you kind of the Excel file that you guys will all see posted in your D2L. And then give you a little bit of information as far as how to get started in some of the calculations. All right, so here's a table showing all of the data that we were collecting before for all trials basically of the experiment now, instead of just kind of the one trial that was actually demonstrated so far in the videos. And so here you'll see for part 1, the hot and the cold water. You see trial 1 and trial 2, the volumes of each that were used. We don't need anything else because it was just water, so there's no concentrations or anything like that to worry about. Where for part 2, we have both a volume and a concentration for our acid and our base, because those are both going to be important to the calculations that we're going to be doing. Now, in terms of the actual data from the LabQuest themselves, you're going to find all of these basically as you scroll down. So as I scroll down, you're going to eventually kind of see all these data points. And if I keep going, it looks like there's a ton, and well, there kind of are. At the end here, it looks like at line 308, that's where the end of the first trial is. And then in line 309 here, you're at basically row 309. You're seeing the start of the second trial, which is basically trial 2 for the hot and cold water. And then if you keep going down, just because of the way the LabQuest uploads this data, there's a run 3 and a run 4. Run 3 is the first trial of the acid-base reaction. Run 4 is the second trial of the acid-base reaction, which if you scroll down far enough, you'll eventually find run 4 that I just passed the start of here. Now, for the acid-base reactions, and really just for both in general, remember you're looking for here for the acid-base reactions, we had very similar temperature starting off, and then eventually we get down to like 300, and we see these temperatures start spiking. And so we're interested in what's the highest temperature things actually get to. Oops. Kind of backed out there so far. And so you're going to scan through. It looks like these temperatures are about the same for a while. It's a good thing. It means our temperature probes are perfectly calibrated to one another. What we're looking for is what's the highest temperature we got up to. It doesn't look like we ever hit 30, but maybe 29.9. That's the high temperature. So that would be basically our final temperature of everything. And the initial temperature should be the last temperatures before anything started to go up. So probably the 24 and 23.3 here. And you see the spikes start to happen as things got mixed together. And so there's what you look for your initial temperatures. Final ones looks like 29.9. I would probably put that for both. So here they both got 29.9. And now you have your temperatures that you need for basically your solutions to be able to start doing the calculations for looking at how much energy that reaction released. I will make one note, and I'll point this out in the video here so that we'll remove some of the confusion. If you're going through your data, for the very last trial, unfortunately my timer to remind me to mix at 300 seconds didn't go off, so I was a little slow. So you actually see the mixing here happening at 362, and so I'm actually going to make a little note that I will save in the file so that when you open this file and go to use it, you will see this too. And I'm going to just say that it was mixed here. And so that you actually know this is where the mixing happened, which means these are, write it a little more clearly, I'm going to say that they're mixed here, so these are your initial temperatures. Right, and so that way, hopefully there's not any confusion as you look at the data from that last set. For trials 1 and 2, in terms of what you're looking at, it's a little bit different. Right, they have very different temperatures at the start, so I'm going to scroll just kind of all the way up to this first trial. So temperatures are very different at the start, and as we go down and get close to 300 seconds, we see that the hot water is kind of cooling, and then right when we get around to 300 seconds, we're going to actually do some mixing. You're going to see a pretty stark change, right? So basically, I'd say probably like right here looks like where temperature started to change. So probably 30.6 and 20, maybe even up just a hair higher, maybe 31.5 and 22.1. There is where it looks like things got mixed. And so I'll actually just make a little comment here for all of these, just so that it's easy for you to tell when you look at your Excel files of where things were mixed, since you weren't the ones doing the experiment yourself. So if these were where things were mixed, that means these are our initial temperatures. And then in terms of the final temperature, it's where did the temperatures kind of coalesce or meet, is what that word really means in this case. So it looks like probably like 26.8 or 26.7. Either one of those looks like they should probably be fine in this case in terms of the temperatures meeting together. So that would be then our final temperature. And I'll let you guys look for the kind of the final temperature parts. I'm not going to label that one. I think that's a little easier to determine. But I'm going to go ahead and label all of the initial ones in terms of where it looks like things got mixed. So for instance, here again, we see things going in. We had probably this is the last one where things hadn't really changed. So I'm going to say mixed here. Trial 2. And again, we see the two different temperatures. Looks like they come together around 28 or 28.1, pretty close together. You can probably use either one of those, it's going to be fine. CCPub is not programmed to take a specific value for these temperatures, so it's going to use whatever you give it to basically do the calculation. So you can kind of choose what you think is best for each. And I'll just make one last label in here for run 3, where I think we actually mixed really close to 300 seconds. Actually, yeah, it looks like spot on 300 seconds probably is where we'll call that one. And that way, as you're going through looking at your data, it'll be a little bit easier to kind of piece through everything that you have. Now, if you do run into any issues trying to use the data for calculations, feel free to send myself, this is Dr. Meyer, an email. I should be available, and you should see me in the D2L listing if you need to. Although I'd probably email me just at the normal UNG email. You can just search for Dr. Ryan Meyer, and I can respond to questions if you have them. Hopefully, this data table sums things up nicely enough, though, that it shouldn't be too bad. Probably what you'll see is that using this data shouldn't be too bad, but it is going to be a significant number of calculations to get to kind of the end data you're trying to eventually find. But that is pretty much everything I have for this week. As always, I like to make kind of a last mention for things like waste or extra safety things to take precautions with. This week, there wasn't really that much of that from a waste standpoint. Since our acid and base, once they were done reacting, they were pretty much neutralized, so everything was actually able to go down the sink pretty nicely. Wasn't a whole lot there we had to worry about in terms of like cleaning things up or anything of that sort. And so waste disposal, not too bad. Everything pretty much could go down the sink this week. In terms of safety, you probably do want to be careful, like 6 molar HCl. That's concentrated enough acid before we diluted it that you want to be careful with that. It will burn your skin. I think I made mentions of that before. And so take caution with your acids and bases. Anytime you have an acid and base solution, you want to take caution. If you feel any kind of tingling sensations or if you feel your skin getting slippery, either one of those, right, the tinglings and acids means usually you've spilled an acid on yourself. That kind of slippery feeling you get in your skin sometimes means you might have gotten a base on your skin that's saponifying your skin. And so always take precautions. Just wash your hands thoroughly. This is a good lab. I pretty much tell everyone after each trial, just go wash your hands really good, or just before you leave the lab, make sure you just wash your hands really good and thoroughly before you go do anything else. None of the concentrations, especially once you've diluted the acid, are so high that they're really, really hazardous to work with if you get a little bit on yourself. But they can be hazardous if you leave them exposed to your skin for a long period of time. And so that's just the biggest thing that we usually look out for. But that is all I have for this week. Thank you for sticking around as I kind of gone through all of this, and we will see you all next time.